Hi, my name is Matt Deitch, and I'm an assistant professor with the University of Florida out of the West Florida Research and Education Center here in Milton, the far west end of the state in Santa Rosa County. I study hydrology and water issues related to water quantity and water quality, and as some of you may know, this is a very exciting place to study these topics because of all the rainfall we get and our water quality issues in this area. I'm working as part of a team looking for ways that we can mitigate the impacts of our development on water quality and flooding to try to reduce those impacts and make things better for our communities in the area. And we're doing that by looking at the possibilities for using green infrastructure, nature-based projects as ways to incorporate natural processes into the landscape, into our developed landscape. And I've put together this video to show some of the really interesting projects that have been implemented in this area to try to mimic these natural processes, these processes of getting the water to sink down into the ground and running off the landscape very quickly where it can cause problems downstream. And so we'll see some of these really interesting features in the landscape where people have implemented these great projects. But before that, I want to show our natural forest area and talk a little about the processes that occur in a forest area compared to a developed area, a big parking lot. So let's start back here in the forest and see what we see.
One of the things that I love to do when I walk through a forest is to think about the hydrologic processes that occur naturally. It's a little nerdy, but it's something that I really enjoy doing. When it rains in a forest, the water first, it doesn't get straight to the ground right away. It goes through the canopy, right? There's a canopy above us. We can see this beautiful canopy of oak trees and pine trees that the water hits, and a lot of the water then is caught by these leaves, right? And the branches and things, so that a lot of the forest trees capture a lot of the rainfall that occurs, and it slowly makes its way down the branches and down the trunks of trees down to the ground. A portion of the water, of course, does reach the ground, right? So it makes it through the canopy, reaches the ground, and it hits the soil, and it doesn't just stay on the soil, right? It infiltrates down into the soil. So below this organic matter, this leaf matter that's broken down here on the surface of the ground, we'll dig a little deeper here, we reach this sandy soil matrix, right? And water goes through this organic material into the sandy soil matrix, and it slowly infiltrates down into the shallow groundwater. So if we were to dig a hole here, maybe 5, 6, 8 feet down, we would hit that shallow water table, and the water's slowly percolating, infiltrating down into the soil matrix to reach that shallow groundwater table. And it moves slowly then subsurface downward toward a creek. And that's how we get water in creeks, right? We get water in creeks through this slow movement of water down through the soil, down into the shallow groundwater, downward toward a creek. When we get heavy rains, the soil can accommodate that heavy rainfall and down into the infiltration. We don't often see water moving over the surface of the ground because it infiltrates down into the soil and it slowly makes its way through subsurface. So we don't often see what's called overland flow. We don't see water washing over the surface when we're in forests. Now we do in areas where we've developed the landscape. And so in a minute, we'll go visit some developed areas and think about the hydrologic processes that have changed in those developed areas, where we put in parking lots and roofs and things to accommodate the commercial development that we use in society. So let's go check out some developed areas and talk about how the hydrologic processes have changed as we've altered the landscape. The surface of the ground looks considerably different here, right? This is what happens when we pave surfaces, when we build our development. We're changing the hydrologic processes that can occur here. Water cannot infiltrate down through this concrete surface. It collects, it runs off in heavy rainfall, and it goes somewhere. So instead of that process of water infiltrating down into the soil and slowly making it through the groundwater table, it rushes off this landscape, usually into some drains. Like there's a stormwater drain right behind me you can't see. It probably goes into a really big culvert that goes into a retention pond, or in older developments like this may go right into the creek nearby, and Pond Creek is right over here. So there are a lot of impacts, a lot of changes to the hydrologic processes in a watershed that occur when we pave the surfaces. And I think it's really highlighted in big parking lots like this. And this one happens to be mostly empty, like many big parking lots in the area. And it also, this building here has a large roof. This vacant building has a large roof that also is a big impervious surface that water can't infiltrate down into. So unlike that forest where we just were, there's nothing catching the rainfall that slows it down like a tree does. There's nothing like that. That soil and that organic matter that slowly allows the water to infiltrate down into the ground. It rushes off into these stormwater drains and down somewhere else, downstream. So as an alternative to what we were looking at before, this is a great example of some surfaces that allow for water to infiltrate down into the ground. So we're standing here, we're at Inner Park, Point Park here in West Pensacola, West Escambia County. The pavement here, let's take a look at the pavement. The pavement is coarse. You can see the coarseness of the pavement. It allows water not just to settle into the pavement spaces, but actually infiltrate down into the pavement. So this is a special kind of material that allows water to infiltrate down into the pavement and slowly make its way through that matrix of pore space down toward this feature over here. And this feature over here is a bioinfiltration cell. So water rolls off this parking lot, and what doesn't get infiltrated down into the pavement, say it's a very heavy rain event, and the water doesn't all go down to the pavement, some of it washes off, it'll wash into this bioinfiltration cell and slowly sink down into this coarse material down here. So it doesn't just wash off into the bay, into a Perdido Bay right over here. It slowly makes its way through this pore space, sinks down into the ground, into the aquifer. So this is a really great perspective on how we can use these types of green infrastructure features to replicate that process of infiltration down into the ground and slow movement instead of rapid runoff that we see in an impervious surface like a parking lot. So yeah, this is a great feature here. Let's walk over this way also. We can take a look at some of the other great features that are at this park. The other great things about this parking lot is that notice there's no curbs here. So there's nothing collecting the water down into some kind of a drain. The water slowly rolls off this parking lot. It's all sloped downward. It rolls this way, doesn't hit a curb. It just keeps going down into this bioinfiltration cell over here. And if we turn around, we can see similar types of features on this side as well. So over here, the water's rolling down into these rain gardens, these low areas. Instead of sitting on the surface or being trapped by curbs, the water rolls down into these low-lying areas and sinks down into the ground over on this side as well. So off of these hardened surfaces down into these rain gardens. So it's a great set of features to show how green infrastructure can be used to replicate natural processes that we might see in a forest in a developed landscape. Here's another great example of a project that's designed to promote infiltration down into the soil and not rapid runoff that we might see in an urban setting. We're at the Institute for Human and Machine Cognition here in Pensacola, and they've designed this property so that the water that runs off the building runs down this landscape into these swales and these bioinfiltration cells on the other side of this fence where water can then sink down into the ground instead of running off into the stormwater system. And the advantage of this is that when we're developing properties, we're not contributing to runoff like we would if it were just to be a parking lot or a solid surface. And also, as we design properties, developers have to incorporate this kind of feature into the landscape anyway. Typically, it's done in a stormwater pond or some kind of depression where the water collects. But it can be a very nice, aesthetically pleasing feature as well, like the one that they've done here at IHMC. Let's go around to the other side of the building, and we'll make one more stop before we move on. We're here at the other side of the IHMC building, and in this case, they've got this parking lot over here where the water that falls, the rainfall that falls, runs off into this grassy swale. So it slowly then makes its way down into this retention pond here. So they've built this kind of treatment train to deal with stormwater, where the water's running off the parking lot into this swale, which slows the water down and allows for some infiltration. And then the water that doesn't infiltrate goes into this retention pond where it sits for an amount of time before it sinks down into the ground and goes through the natural processes of infiltration down toward the bay. We're in another park here in Escambia County. This is Hitzman Optimist Park, and this park was just renovated with a lot of great stormwater features to mimic natural processes, especially those ideas of infiltration instead of that rapid runoff we see in urban areas. So unlike the park we were at just a few minutes ago, this does not have permeable pavement. This has more traditional asphalt pavement, but the water that runs off the surface goes into these bioinfiltration cells over here. So the water runs off this surface. There's no curb here to concentrate the runoff. It slides off the parking lot into these bioinfiltration cells that allow the water to infiltrate down into the ground. One of the things I want to point out about this is that I think a lot of people think of green infrastructure as being this kind of haphazardly designed thing that just gets dug and left in the ground. But the reality is it's a very seriously engineered feature. And we can see, like with this one, there's a great example of this stormwater overflow that allows water, before it backs up and fills up this parking lot, it provides some overflow if there's a very, very heavy rain event that's too large for this feature to accommodate. I see a similar feature over here on this side of the parking lot, where we've got the same idea, where the water runs off this parking lot, doesn't hit a curb, but goes into these rain gardens and bioinfiltration cells over here. So a really clever way to accommodate the runoff without concentrating it and causing problems farther downstream. So now I'm here along Langley Avenue, which I'm still at Hitzman Optimus Park. We were just over there in the parking lot a few minutes ago. But now along Langley Avenue, the city has put in these great stormwater features along the road here. And in particular, it's got this really nice design of this roadside swale that allows water to go into this mix of gravel and plants and infiltrate down into the ground or into some subsurface stormwater conveyance, instead of just rolling off the landscape, rolling down the road and into a storm drain downstream. So the way these are designed, the water comes off the road through these curbs and goes into this gravel. Now there's some debris that's accumulated here that probably needs to be removed. There's some maintenance is required with these features, but like any place, maintenance is required. And so during a heavy rain event, water will run down into these inlets and infiltrate down into this coarse gravel and cobble matrix, and go down into this stormwater infrastructure that's subsurface, that's below the ground here. They've put in some kind of overflow in case these fill up, so that if there is a lot of rain and this can't accommodate the green infrastructure can't accommodate, there is some overflow capacity that goes into storm drains downstream. But yeah, it's a really interesting feature. It goes on for probably about 1,000 feet right here along this park. And then on the other side, we've still got these rain gardens and bioinfiltration cells that accommodate water off the parking lot. So I think it's a pretty creative way to deal with stormwater in this park that's been developed recently to accommodate these ball fields and other recreation opportunities in this urban area. Now I'm at a dentist's office in Pensacola. This is actually Cards on the Table. This is where I go for my dentist. But every time I sit in the dentist chair, I look out to this beautiful garden that's been put in here. This is actually a functioning rain garden designed to accommodate the runoff from these buildings. And the reason why I like to visit this and feature this is because one of the things that I think we can do in our communities is, as we develop properties, we have to make decisions about how we're going to accommodate the stormwater. We can either put in a pit on the side of the property or behind the building, or we can design a nice looking feature like this. And to me, a nice looking feature like this has a much higher value, both in terms of the economic value of the property, but also the value of the people who are going to this for services. So to me, this kind of rain garden is an ideal feature to incorporate for stormwater design in the area. And it's designed similar to the parks we were looking at before. Water runs off this parking lot down into this concrete, and then ultimately these rocks down here, and into this stormwater, this very aesthetically pleasing stormwater feature. We can build these types of features into the landscape as we're developing properties, instead of a more traditional, less pleasant, similarly functioning stormwater pond that we often see in buildings. We're back to where we started. The recording room where I recorded the video at the beginning is just right inside this building here. But I want to talk a little about possible solutions to some of these issues of development that I've been talking about. I showed a lot of examples of green infrastructure in parks and green infrastructure in small businesses where there's development. But I think one of the challenges that I face as a homeowner is thinking about what I can do personally to reduce the impact of the impervious surface on my property. And I think about that a lot in the context of my office building here, which is not a residential scale. It's a lot bigger, of course. But some of the issues that I've seen arise here, I think, apply to the residential scale as well. And one of the big effects one of the big things I've had the opportunity to see is, as they did the roof on my building. The roof on my building was recently changed to this really nice roof, but one of the things that they did that's different is they put in gutters and downspouts. So instead of the water rolling off the roof and into a row of a thin band of gravel around the building and allowing infiltration to occur that way, they now have these gutters and downspouts which get the water away from the building very quickly. But in doing so, it concentrates the amount of water, it concentrates that flow, it concentrates the rainfall into a much greater amount of water concentrated into a smaller area. So water then goes through these, I think there are 5 downspouts on this side of the building, 5 on the other, the same over here, and it concentrates the rainfall into this little patch of lawn here, and down, the water then flows downstream and this way into this open area here. And what it's done then is that it's created a lot of gullying in this area. So the water then has gullied in here. They filled a lot of this in with sand and gravel where they could. But that concentration of flow then continues down and has caused a lot of gullying down here before it reaches this stormwater pond. The gullying at the bottom of the property then, just before the stormwater basin, has caused a lot of erosion, a lot of deposition of fine sediment. And I think this is great. It's a great opportunity to see these types of processes that occur as a consequence of our development. So that with the infrastructure that's here, we can see the deposition. But if it weren't here, if all that fine sediment were to go into a stormwater drain, that would end up in the nearby creek, in Pond Creek, instead of staying on the surface, which it would have done in the absence of that concentrated flow from the downspouts. So my point is, if we're really serious about reducing the impact of our impervious surfaces, one thing we could do at a residential scale is we could disconnect our downspouts and think about how we can accommodate the runoff off of our buildings, off our garages and our houses into rain gardens, similar, maybe a smaller scale to what we were looking at before, but into areas of gravel or pine needles or something that can accommodate that runoff instead of allowing it to wash off the driveways into our roadways.
I think the projects that we visited today all show some pretty novel approaches to dealing with stormwater in our area. And I think that these projects are all very new. They've all been implemented in the past few years. And I think that county and municipal and planners and also landowners and developers recognize the value, not just in dealing with stormwater, but the aesthetic value that these types of projects bring to the area. I expect we'll see a lot more of these over the next few years. My project team will work a lot over the next couple of years to think about how these types of projects can be implemented in communities at the residential community scale, to think about how we can reduce flooding in these areas as well. So I think this is a great place to study this topic, and I look forward to working with the community in this area to improve water quality and reduce flooding over the next few years.